Okay, everybody. So it's the 12:35, and we have 64 people on board. So we're going to we can start with the workshop. So I just want to know, like, if my voice is it clearly audible or not, or should I have to speak a bit more strength?
You're perfect.
Oh, okay, sounds good. Yeah, it's morning time and my sleep schedule is a little bit messed up, so just pretty calm in the mornings. Just trying to. Okay, so welcome everybody to Python Introduction Workshop. So we are STEM Fellowship Data Science team. I think so. Folks already have another workshop just 2 hours back. Is that correct? Right, about the SAS and how to use SAS and other stuff. I don't know what about the SAS or anything relating to it. So that's our second workshop today. Python is, to give a little bit introduction about Python is most probably people would have known or heard Python from some sources. Either it could be, okay, it's mostly very high level language, and it's pretty easy as compared to if you are coming from by high programming intensity background, writing C++ or C. You have to look up for lots of memory allocations. You have to keep track of if the variables are destroyed or not, or sometimes there's going to be a lot of segmentation faults, but it's not the case with Python. Or like people could have some other experiences like automating some small stuff with the Python. So it's mostly a scripting language, but it has much more built into it because of a great community that has a lot to offer, right? Okay, so probably, as in my knowledge, it is that the workshop, the Python notebook has already been shared with everybody in advance. So if you have already gone through
Prithvi, you are muted right now.
Can you hear me now?
Yes.
So what? Okay, so I'll just go over again. So that's what I was saying, that so there's a lot of stuff that you can do with a Python, but in our PDC undergraduate challenge, mostly it has to revolve around the data analytics, and there's going to most typical project looks like that you have to start with the data set. So whenever you have a data set, now the second thing is to just see what the first step of all the data analytics is, just to explore the data about how the data is and what are the columns, what data types they are. Then you have to just try to do data manipulation, or ETL, stands for extraction, transformation, and load sort of processes. Then you can do some statistics, and in the end, you can do some visualization. So the Python has a lot of libraries. If I have quoted some of the famous libraries which have great Python community, which mostly open source, and there the people are actively developing on it. So it has support for natural language. If you are interested in computer vision, there's computer vision and neural network and whatnot. Probably if you are more interested in making some advanced projects, you would at one time or another would, going to encounter one of these libraries. So just starting from the basics, it's pretty simple about the variables and data types. So we got strings, we got numbers. Numbers can be two types. It can be either just a whole number or it's a decimal, right? So we are not making any distinction about is it a single or like float points or double, like it's all the same in Python. But technically speaking, in other languages, there are some distinctions about how many bits of memory is a 32-bit used for single, 64-bit is used for double. But in this case, you don't have to worry about this stuff. Like all the Python interpreter is going to take care of how the things are going under the hood. And then we have Boolean also, which could be either true and false. So just want to go over that in Python. We usually begin with the cap T or cap F for false. So I happen to do this a lot of times, and it's going to give me error because this is not a perfect keyword. Okay, yeah, so that it's not true. It's just remember there's like pretty small detail to remember, but you can get used to it. It's caps T, caps F for true and false, right? So the variables are, so anybody who hasn't done any programming yet, so variables store some sort of information. Strings are mostly used for just display purposes for human readability. Otherwise, it could be numbers, or it has to store binary value, which is either true or false. Then let's go over to other mathematical operations that we can do with it. So let's say if we want to plus, we can just add all of them one by one, and we store all the result in another variable. Or you can just do these things are being subtracted from what's A over here. We can just run this whole thing. Yes. So if A is 0 over here, so that's how the values are being interpreted in the variables. Now there's multiplication, division, and if you know more about how, like there are some other operators too. For instance, if you know about the modulus or getting the remainder out, then we usually use percent sign. It's not written here. I can do it like this. So let's say modular could be 7 or maybe 10% too. So that should give out 0 because 2 is completely divisible by 10. Okay, I'm not printing this stuff up. So if you want to print, just put up the print and put the variable inside. Okay, I don't know which one corresponds to which. Probably it's this one. That's what we were expecting. But now in this case, if we have 7, it should give out 1 because 2 is divisible by 6. Then we add 1, we get the 7. So it's 1. So that's another modular function. And there's, yes. That's pretty much the function, like the operator that we need at the basic level, not going too much into complexities. So the next thing is just a brief about the data types. So data types are not strictly enforced in Python. So most of the time when your code go bigger, like the ambiguities also scales with the same amount. So for instance, I'll talk about that later on, but let's say, okay, so we got 3 variables here. String, 2 numerical types. One is interpreted as float. So for instance, so if I have declared the C as a decimal, so what's going to happen is if I'm going to perform any mathematical operation, it's always going to, so the interpreter is always going to see it as a decimal. And so for instance, even if I were to do this thing, So it's going to give me 24.0 as opposed to just 24 in this case. Right? So this is the multiplication again. And if you want to check what type is it, just there's a function globally available. You don't have to import anything for it. So just put the variable inside. So this is the function, and I'm printing the whole thing out. So as you can see, the result at the bottom, one is integer, string, and float. So yeah, so Python can interpret this as a float. This thing. Then we go. Now the thing is, we can always convert from one data type to another. For in this case, this thing is being converted from string to float. In this case, it's going from just whole number to float, and this is float already, right? So as you can see, now with another function int, we can go from string to integers here. And the same thing is when we have different numerical data types, we can convert them to strings, so that if you want to print out or just store it into some logs, it's pretty easy. Same as how we are doing over here. So this is now, if you want to just print anything to the standard console out, what you have to do is we just put up anything over here, then we put these placeholders, and if I recall the function. So this is a string object. So each string object has already a lot of functions that you can access. So one of them is to access those objects, you can just write format dot and what's the name. So it's going to, I can place whatever, it's going to come here, here, here. So let's say 1, 2, 3. And so this is going to be a string. So for instance, that means I can store it in another variable, and I can print it out also. Yeah, so I can see some stuff over here. So that's one of the thing. Other available function string function could be, let's say if I want to print every, okay, so it's already lower. How about we do with uppercase? We convert it to yes, right. So you can read about the official documentation on Python, or just Google it. You can find a bunch of stuff you can do with the strings. Now let's go over to the functions. Okay. Okay, so the functions are a piece of code that's declared at some other place, and you can call it at another file or within the same code. So the whole purpose of function is that this function, for instance, so you can probably it's going to be intuitive about what the function is going to do. So it's a sort of a black box for now if you don't understand. So we have some sort of inputs. You can have code, whatever inside, and okay, so this I can make it a little bit longer than. So I just want to, so sum is, I want to compute the sum within the function. Now, if you can see, I tried to name this variable as sum, but the sum is already another function. So probably I can't pick up an already existing keyword. So let's say my sum. Okay. If I do this and try to return my sum, it should be good as well. So now, mostly in other languages, so this is a one block, which corresponds to that. This is the definition of the function. So for function, just remember that it based everything in block usage in Python is based on indentation. So one indentation means this block belongs to this function, right? So let's see how it plays out when we try to call it. We have two numerical variables. Then I put what I call the function on these two variables to result in 3, and it's going to print some stuff out. As you can see over here, the third placeholder is our the result of the variable over here. So it's giving us the whole sum. That's fine. Now some other stuff that you want to do is now we can talk about a little bit about the different data types. So again, in different languages, there's a very strict policy in the syntax to actually declare what type of data type you want to return. In Python, it's not that strict. So for instance, I can return like multiple things. So for instance, a true false can be interpreted as 0 also. So let's say it should be fine over here. So let's see. So by the way, so this function itself is just trying to see if a number is prime or not, or divisible by 2. That's actually shouldn't be prime. That's my bad. It's just divisible by 2. Because not all numbers which are divisible by 2 are prime. For instance, 7. Because to find, so there's probably another algorithms to find the prime number. Mostly you have to, depends upon how efficient algorithm you want to play out. Now there's another function we have declared which just prints out some stuff, do some operations on this thing. And so here's the definition of the function. This is, where's that being called out? Yeah, it's being called out in the end. Okay, that's fine as well. So as you can see, what we are trying to do is, let's say, it's pretty obvious. If we were to pass numbers in here, then this quantity is just going to be mathematical multiplication. But there's some other stuff. So in this case, if you were to multiply a string by an integer, what it's going to do is just going to multiply itself by 4. So that's why, as you can see over here. So these are just probably, I have not much knowledge about if it was intentional or is it just a side effect of how the interpreter works, but that's how it is. So sometimes it's pretty useful to know about this stuff because it can really mess up if you don't know about what's going on. Go big. Now the next thing is about the data structure. So data structure is, as of now, we just dealt with a variable. Single variable is being storing just single stuff, either string or numerical variable or output of another function. In this case, data structure can hold multiple values in it, and the way there are different data structures that help us to organize data in different ways. So for instance, they are different in terms that, like, some situations will help you to use set, or another situation will help you to, it's much more efficient to use list in that case. Just a markup over here. So let's go to the list first. So the list is the collection of variables over here. This is storing six integers. This is storing just, so you have brackets, that means the list. This is just one object within the list, and this is again how many other? 5, yes. So now there's another function to get some information about the list, like length. Now there is I probably didn't had enough questions as I'm seeing out, so probably I'm just trying to stay as basic and low as possible for the people who I assume haven't had too much programming experience. So if you think that it's pretty basic for you, just try to post up some questions so that I can answer. Yeah, just to remind. Yeah, but I was not checking up here. So probably what I can do is I can open this up into another window. So it's probably in front of my eyes. Okay. Okay, so we were talking about the lists. We declare up the lists. This is the definition. Then we can access the individual element by their indices. So index is singular and indices are multiple indexes. So in this case, indexes always begin from 0. So if I write to access 0th element, that always going to give me the 1. And 0, so this is 1th element, second element. This is A3, this is A4. So that's how things of what I have written over here. I'm not going to elaborate too much onto it. And so this is a single object indexing. So I'm always going to get a single object out of here. So for instance, again, in Python, we don't have strict policy about return types, data types, or even what's there in the list. So I can have a string in list full of numbers. It's not something illegal within Python, so it should be compiled flawlessly. So in that case, let's say first element where this thing is being used. Okay, so if I'm trying to access this, let's say if I want to access this string, so how much it's located at 0, 1, 2, 3, 4. Okay, now I know this is okay. Let's create another variable instead. It's 4 over here, so I know this thing contains this string, so I can actually it's a string, and string is also enumerable. So this is another list in itself. So that means you can use the same notation to get a single value from string. So for instance, if I want to get an R or single N, I can use say third. Yeah. Where is our variable? Yeah, so as you can see, the list itself is also string itself is also a list. So you can index it anywhere you want, and you're going to get out the single character in that case. So that's what we did here. And if you want to get multiple characters, you can use this notation. It's start from 2 and end at this -1. So that's very crucial piece of details, because when you're going to write loops ahead, it's pretty important that you know where it's. In this case, it's going to start from third element because it's a 2, and it's going to end at 7. That means it's so let's say, what do we have in here? 0 for string. We have slice chunk rst/t_t. Okay. In here, what we have is, so we start from 0, 1, 2, 3, 4, 5, 6, 7. Yes, so it doesn't goes to 8. So that's what you have to remember. So the second one is always one less than the ending. So it's going to go till 7 only. So there are other stuff, and if you're using negative notation, it's going to start from back. So -1 is the last element, -2 is the second last element. Yeah. And this is a push function. So always, if you have a list, in the variable a is the list, and if you write append, it's going to append at the back, at the back. It's going to here, then here, then here, then here, then here. Or you can, if you want to actually change the existing value, you can access it through its index and write is equal to something else in that case. Another data structure we have is the set. The set is not same, it's pretty different from list. It has some sort of properties and functions that are useful in set theory. So for instance, you can do unions, intersection, and other sort of stuff. So we put up a list inside, and one crucial detail about the set is it's always different. It's not going to give you the same repetition. So as you can see over here. And there's another set that we defined, and there are some other functions which you can use for the set. And in this case, it's going to return the intersection, which is the AND operation. Union is going to be OR operation. So again, so each set has, or so if it's a set, so there's a particular syntax you have to use, which is to use a set keyword, and within brackets you put in list of series of stuff. Then you can access those functions in here. So probably you can learn more about the set functions on like different documentations. For instance, if I were to go on to the official one, this is pretty exhaustive lists of all the functions that you have. These are the stuff that you can use if you want to find union, intersection, differences, new set of shallow copy, or if you just want to check if something is in a list or not. There's a lot of stuff you can do with a set. So again, what's the difference in what we have learned so far? Lists order matters because you have to access it through index, and multiple data types are, it's okay. Probably multiple data types should be okay in this too. Let's see. Yeah, multiple data types are acceptable as well. Okay, that's cool. Now the third data structure is a hash map or a dictionary, to be like as the official name for the data structure in Python. So it has keys and values. So for instance, we started with this is an empty hash map, and this is the filled hash map. So you can access some value with a key. So in this case, we can access what the position is, and it's going to return me whatever the corresponding value it is. So it's always going to be a single mapping, right? So and what does that mean is if I were to define another key which is already existing, so Python is going to be confused about, okay, which one should I select? It's going to, okay. It's not going to return you. It's not an illegal command. Just for you, it's just good to know that it's always going to return the. If it's a position, right? Okay, so it should be A. Let's do another one. Let's do it here. We are writing copy. Yeah, so it's always going to return the last one, right? That's how how things are going. So it's better to just keep it as distinct as possible, because it's good for human readability, because if it's a cartoon, then I'm expecting something of Boolean type, not something else. So the features of, again, in a nutshell, what are the features of a dictionary? Key and values. You can use a key to access whatever the value is, and why it's good for me, because I know if I'm going to access a position, and the way I have defined my dictionary, it's always going to return some sort of, let's say, coordinate data type, which could be either whole number or numerical, not something like dot case. Then there's here I've defined a function that takes in dictionary object, and it returns whatever returns values at name, cartoon, and position key. Yes, so probably it's going to raise some error if I were to give it an empty list, because it's expecting this to be okay. Yeah, so what's happening is there's a being mistake over here. So this is accessing a variable which is defined over here, but within the function we don't deal with the global values, we deal with whatever has been passed. Let's change over here. That's a crucial detail that we missed here on. Now it should give up some error because it's expecting name, cartoon, position. It's not in an empty object, but it's in the A. That it should be done. Should be good enough. Yes. Now, but probably we could have gone through so what have we discussed so far? There's dictionary, there's set. Oh yeah, we haven't gone through the tuple. So the tuple is same as lists. The only problem with a tuple is you can't update anything else. So for instance, okay, you can access single elements by indices, as same with these lists, but you can't change it. So that's what a tuple is. So there's a question about if we can download the Excel data, turn to CSV, and put into our studio. Is this similar? Yeah, so your question is that how you're going to interpret CSV files, right? So for instance, the packages that comes on top of Remandis, if you were to use pandas read CSV. So this is one of the functions that probably I have, no, I don't have that open yet. So for instance, if you have to import this library, so how you can import this, I can just write, I can actually demonstrate over here. Let's say I import pandas, and that's provided that I have already pandas on my system. So you have to use pip install the library name, or if you don't have pip, then you have to even install pip on whatever operating system you have. Okay, let's not do it here. Let's just do it over here. This is Panda. So this is this sort of stuff comes more in if I were to do a workshop on data manipulation, but it's a quick question. I'll just go quickly about how it's done in Python as an over general stuff. If I want to CSV file, I can, where's the CSV stuff is stored. So this is I'm running on cloud, so it can access my local files. So probably I will add some part2 directory and some other variables if you want to do. Lots of variables you can find, but not all of them are, mostly they are optional. So read CSV, and it's stored in a data frame, so you can data frame is pretty good. The table you will get out of it, and if you want to, so you make changes, let's say I change the name of somebody, and if I want to now write a new CSV file, what do you just do CSV output file name CSV. So that's a sort of a prototype you can do in Python. Let's going to the if-else statement. Now in this case, what we are doing is we are accepting user input. So you can do so with the input function. Let's say I go to 2, 3, 4. But what is it doing is it's going to return the average of all 3 numbers, okay? And if you see, whatever am I inputting, I'm simultaneously converting to float because I don't want any unexpected and error. So I know for sure that these 3 are floats, and if I divide by 3, it's going to be a float again. But if I just do an int, in that case, like, it's okay. But if you're dealing with floats, you have to make sure that each individual is float because it's very good for like whole data precision. To run again. So it looks like, okay, so we have half an hour more. There's a little more stuff. I'll just try to go quickly over them because I spend a lot more time on data structures and a little bit more about the Python background. The other stuff. So if you get started on learning about the syntaxes, it will just come naturally because most of you are undergrad students. So not going to spoon feed like every single detail that you can obviously go read online, right? So there's some problem coming up. What's the problem? If I enter 1, okay, 2, probably I press some wrong key. Okay, it's going to return. Okay, 3.3. It's acceptable as well. But if I were to do a string, it's already a string. This whole thing is a string, so it's a redundant method, but still, just to demonstrate the fact what's going to happen if these 3 are string and I try to divide. If I try to add them and then divide by 3, let's see what comes out. And I'll try to give you explanation for that. Yes, that's the thing, right? So you can't add strings to you can add strings to each other, but you can't divide them. So division is the illegal operation over here. Because if I were to do this, it should be okay. Yes, so it's a problem over here because I try to actually define if it's a float type, then you have to return 3 decimal places. But if I don't do it, just print out average. This something comes up over here because it's obviously expecting float, but like this is all fine. When you plus them, that means you just append to each other, right? So the whole answer is appended value. So just going back to float. that's what happens, right? When the computer can't process how write that fast, it's going slow. Okay. So it's going to the if statement. So if has a statement over here, and again, as I mentioned before, a block is through indentation. So if I want to print multiple things, or if I want to just do some other stuff, I know all of these are part of the if statement because of indentation. But if I try to define another if statement, so I'm just trying to check if it's 0 or not. So I have another indentation here for the if statement. Okay, and yeah, most. Yeah, so it hasn't come up because it's not 0, right? So I want it to come up because it's 2 over here. Probably it's very slow on Google servers. That's why it's not picking up too quickly. Okay, so but you understand what's the catch with the if statements, right? You have to use indentation. Just remember, sometimes when you switch between the languages, either sometimes you're writing C, then or Java, or just going back to Python, or you're writing R. Then a quick thing in our mind, just check there's a semicolon over here, and there's indentation. Like it makes life a lot easier if you have some like that thing in your consciousness. Okay, then. The next thing is if you certain meet a condition, that's the first block. And otherwise, it's another block. So you can do it with the else keyword. And same thing. So the else doesn't expect any statement because it's otherwise or whatever it's before, right? So in this case, if I enter 2, okay, there's some indentation problem coming up over here. So in the line, I just want to get rid of this whole thing. Let's see if block. Oh, okay, so it's already expecting. So it was an IO bound operation, so it was expecting me to enter. Now it will go here, probably. It should be asking for another input from me. Never mind. So like I'll just skip over, and it's going to ask me for an input, test on a condition, print out something, or do whatever stuff you want. Otherwise, it's going to. Let's see. Okay. I know. It's nice weather outside. Now we comes to different sort of different values with the if. So this is if statement. So again, some variables already defined. I take a user input and compare that input with 90. If it's score is 90 greater than 90, this thing. Otherwise, it goes in this block. It checks for another condition. If it's true, if it's this. Otherwise, it's going to here. Then I check for this condition. This is true. Oh, sorry. This is true. It's going to return the same thing goes till the end. But as you can see, it's going to go nested and nasty in terms of readability. So what we can do is we can just write else if statements. So this is pretty neat as compared to this format. And the whole sequence of operations is first this is checked. If this is true, this is going to be it's going to print and it's just going to exit to like instructions here. Or if this is not true, then it's going to check here. If this is okay, then it's going to print this thing and exit the loop. Or at worst case, it doesn't satisfy this, but it's going to return the default value, which is after it if it's really worse. Yes, because sometimes, so for instance, now there are another keywords such as, well, we can use that in loops. Okay, so that was the, so if else in overall, it has an if statement, else if to check another statement. If none of them works, then there's default. So probably it's very good practice to write defaults because you don't know what the user is writing. I can write whatever garbage values in here, and maybe your program doesn't handle that. So how about just writing up like a default value, or just checking the user input above, right? That what are the validation stuff you can do with the user input? The score should be some sort of integer, and there should be a low and high values. It can't be negative. But like this sort of stuff is good to know, and just to learn about your program and how it's going to handle stuff, because it's you can't just run program every time to see if it's working or not. So because if you're working production level stuff, you have to do static analysis, which is to just read the code and try to deduce what sort of possibilities are there, and on what values it can crash. It can crash on probably a lot of stuff. Okay, so another control for construct is loops. So a loop, how we write is we have for x, and so there are two notations. Like in overall, there could be a million other notations, because there's a lot of libraries people have developed another for loop notations. General is okay, so it's going to iterate. So this is what you call an iterator. So let's say element and iteratable object. So what an iteratable object is, something which can be iterated. So I don't know how to explain that into plain English, but it should be, we can have list like this. So this is iteratable because I can count this 1 2 3 4 5 6, or if it's a string, this is also an iteratable because I can count on this 1 2 3 4 5 6 and 8, and I can access them through notations, right? So if it's a sort of a string or list, or that's probably an iteratable. You can also make classes and objects which are also iteratable, so that can also come over here, but that's something advanced. Not going to cover much here. But as you can see, it's going to iterate through each of them and store the current value in x. If it's an h, print this, otherwise print this. So mostly there's just single h, so it's going to just do this one time, and for the other times it's going to turn this. How many there are? So there are 5 5 10 11. So one time this, 10 times this. Should be here. Now another notation that we talked about is range, which is just a Python function to print out an automated lists. Once if I just want to comment this out, I have, I convert whatever is inside. So this is a notation to. Okay, I'll do it later on. So this thing is going to just count from 1 to 100. But as you can see, this looks like a list because it's another object, right? So it's another data type, which is a range data type. We can create our own data types through using classes. But if I were to convert it to lists, it should look like a list. Yeah, that's a list, right? Okay, good. So yeah, so if you have some sort of a pattern that it starts from this, it's a starting position, ending position, and you can also write how many steps you have to go. So it's going to 1 3 5 7. So it's skipping 2 steps now. So there are 3 arguments to range. So it's pretty good for numerical iterations where you know how many times you want to execute something. So yeah, so it's going to go from, again, it's going to start from 1, but it's going to go only 99, as I said before. Yes, because it was also the same thing. And where was that? Yes, in this indexing, as I said, indexing. So it's a sort of a same pattern that comes in a lot of places, that when you're using starting and end position, starts at that index value. So second index value, okay, but it's going to end at this -1. So it's going to end at 7th index, not 8. So it's you should know that, because many a times when you go off this detail, you just stuck up with your program about why it's not going here. So it's going to 99. Should be 99. Yes, it doesn't go over 100. So that's good to know. That's what I talked about. Okay. Yes. Now this thing goes from this 1 to ending -1. So probably 4. How many there are? 3, 6, 7. So probably 4 and 5 times 9. That's what it should go to. Okay. I'm probably not going to, yeah, so it's not printing out, so that's fine. It's just calculating stuff. This pretty big number is going to take a while, and I don't have much time to go. And let's say there's tuples. You can, so as we saw before, there's tuples, and within the tuples, same as list, you can have multiple stuff simultaneously. Over here, for instance, on this thing, I'm gonna have 0.5, point, not 2 times. It's okay. So if because I can assign multiple data types to list, same as for tuple, only difference again to remind, tuple can't change its value after being declared. So what to do? Okay, I have to put an interrupt first. It's still calculating. Okay, now it's going to turn this. Okay, so there's there's a problem with the indentation, right? The computer is thinking that this thing is inside T, but it shouldn't be. It's outside over here and one level indentation here. Yeah, so it can't do assignments. So it's pretty good for those stuff when you want to be sure that even I can't, as a programmer, can change, or a program itself can't change it, unknowingly. So that was very brief, and about the most basic building blocks. So everything is going to start from if-else statements, loops, and data type. So probably it could look like very basic at the time, but I can assure you that there was a lot of stuff even in this basic workshop that I haven't known for a long time until I just started looking up into Python basics again, for instance, about the data types, and that had costed me a lot of time about if I had not known that like basic fact about how the lists work, and it goes from starting index to ending index -1. I know why is it doing that, because that's how the Python does. So there's data types. It's good to know about data types, and whenever you write program or functions, it's always good if you are doing a uniformity, that you are always expecting a my-sum. So for instance, if I were to put a if statement, if they are same, this thing, okay. Otherwise, there's no need for write an else statement, because I know that whenever return is this instruction is executed, it's just going to exit the function. So I can write whatever stuff is here. It's the same as having else statement, because we always know that whenever this thing is executed, it will exit here. This thing will not be executed. But if this is not true, this will be executed. So that's the same behavior as else. But it's good to write else because it's much more readable and easy to understand. So they should be same syntactically, meaningful. But in this case, okay, how to do? Run this program. Okay, so that's another detail that I cautioned you about. I forget to put this. Okay, so that was fine as well. But in many other languages, when you define a function, because my return statement is inside, if it says your function doesn't return anything, so that's why I was in the favor of writing at least one return statement outside of any loop or if statement, which is directly in function block, because this does makes more sense. In this case, we know at all costs it's going to return at least something, either this, otherwise this. But if it's inside an else, let's say if it's else if statement, right? First input is 10. In this case, there's a corner case where we don't either do this or do this. Like for instance, if I have 11 and it's not even same to itself, 76. In that case, function doesn't do anything because this condition is false. They are not same. First one is not 10. So that's why as a default case, you have to write at least one return statement, which is outside of any statement. So that's a good convention to follow. So that was there was some stuff that keep on coming on my mind, and just try to cover stuff as much as possible. But it's good to hear from you people who are listening. I don't know how many. Let me check. There, okay, so there are 51 folks connected. Now it's time for questions. So I'll be, let's say we are 6 minutes, but I can go over to even 140. So just start firing up your questions if you have, as basic as or as like as advanced as if I know, I can try to answer that as like simultaneously. Otherwise, I can otherwise I can tell what's going to be my problem solving. I don't know. Yeah, so that was a little about the Python and other it's probably you're going to spend a lot of time reading up like documentation like this, because sometimes I forget how does, like, if I were to add a float or a string, how is it going to behave? Obviously, I can write and check it itself by printing the value, but in many other cases, when you're dealing with a complex code, you have to know what's going to be the return data type or how the things are going to behave. So you have to actually know. So for instance, I was talking about reading CSV file. Because I already knew in advance this function is going to return a data frame. So data frame is not a list, tuple, dictionary, and there was another one. I forget. It's a data frame object. It's a data frame data type. So that's another data type. It's basically a class. So I know if I can. So in that case, well, I'm just keep on talking, until I get any questions. So. Yeah, so somebody posted that the workshop finished at 5, not 4:30. No worries. So I don't know what that was supposed to be. So I'm here in Vancouver. It's 1:30 over here. Okay. So that means you were expecting half an hour more of workshop. So mostly I've covered all the basic stuff. And please put up your questions, because you're going to learn more from asking me rather than what you have seen, it's me speaking and going through the code. It's not good for your learning. Good for your learning is to ask questions and do things stuff yourself. I'll be just hanging around for some of the questions I'll try to ask. Are we expect to use the Jupyter Notebook for Python? It's why do I use Python Jupyter Notebook? I can show you. Let's see. So one use case is, let's say I pull up like a Python code over here. So this was the code that I tried to use to set up the Slack workspace. For instance, there's a lot of stuff. Okay. I want to. This. Oh man. I can change my screen. Okay. I'll just switch over here. This. I think so much you can see the screen now. Okay, yes. So you can see some stuff, right? So this is a big chunk of code. So in that case, for instance, if I were to open up a function, right? So there's a lot of functions. There's a lot of functions. So in this case, I'm reading up. So that's it. This, just ignore the stuff and what the self means. Just treat it as a one piece of even. I don't need this because this part of code is not working. In this case, what this code is doing, it's reading from a CSV file and assigning mentors to their respective groups. So as you can see, now there are other stuff. For instance, you can see the try and accept. Like this is not usually, it's useful when you are trying to catch errors on fly, right? So for instance, okay, let's begin. So I'm reading up CSV files. So this is, I'm using a specific library called CSV. So if I go to the top where I see all inputs, there are CSV, this is the CSV file we have. And I can, a quick way to actually see if an object is in your computer or not is just to write the Python -c and just write input CSV. If it doesn't give me an error, that means it's already installed, because sometimes I don't know what is installed or not. So if you want to actually see what sort of libraries are installed, you have to you can do this. Okay, so there's a ton of libraries that I have in my system. So these are all installed. I can see, yeah, I have the Jupyter over here. There's Django, there's a lot of stuff. Right, so otherwise, if I don't want to go here, there are two ways. You can execute Python in your terminal directly over here, for instance. Well, there are no. So a semicolon in this case means it's end of form statement. So it should be fine. Okay. Yes. So what I tried to demonstrate here was. Yeah, so in this case, what the question was, like, when to use Jupyter Notebook. Like, I first want to test, like, does this function works or not? But for this, I have to run the whole file. So like this. But if I just want to see, if I want to test this piece of code, what I'm going to do is I'm just going to create a Jupyter Notebook over here in this specific folder. It's going to set up with the server. Server is somewhere else. I can't show you the screen itself. So this is the, I don't know why it doesn't show. It's a full screen. Yes, that's what we want. So as you can see, these are all the files, and this is already a Jupyter Notebook that I have. So the fun thing about the Jupyter Notebook is I can execute each individual piece of line as I was doing with our, like, this is online hosted notebook, right? So this is not on my computer. This is on Google servers. As you can see, the RAM and disk. This is on my local here because I can see the server logs. So I can do whatever I'm doing here, but I can test one thing one by one, because sometimes I'm not sure about why some error is coming up and it's hard to debug. So I just take that particular function and try to investigate it, like, piece by piece. So that's one use case why to use, for instance. Yeah, it's going to be complicated actually, but I can, yeah. So Jupyter Notebook is very good if when you're developing code, but if you want to make a script or actually a single piece of file, then go from Jupyter, copy all your on the Python file, so you can execute everything by a single command, right? So Jupyter is mostly for testing and writing stuff because you don't know how it's going to expect. Yeah, just post up any questions. I'm going to extend it to, let's say, 8 minutes more. So I'll be just waiting for questions if you have. Can you show how to put this into an actual Python program? So what thing are you talking about? Somebody posted up a question, so I don't know what the context is. CSV file, workshop. I'm just, thank you. Cool. Yeah, there's a lot of fun stuff you can do with a Python. Mostly it's like people used to automate some of the stuff. Okay. Just let me know if any other questions. If you know Python, you have done some projects. So if you still have some questions about, what sort of library you can use to do this sort of stuff. So any questions? Doesn't look like people are. Okay, so it's 36. I'll wait 4 more minutes just for any questions or any conversation. I can't hear anybody. If people just want to say hi, just do so. Yes. There are some fun things about, let's say, I did once a project on where I need some GPUs because I'm using some TensorFlow library. That's for training your neural nets. So Google Colab is a great resource if you don't have GPU in your own computer, right? So I think so. There used to be a setting where I can see actually how many GPUs, free GPUs, without any costs on free account have been allocated. Let's see, manage sessions. Okay, so order running. Where can I see runtime? Change runtime type. Yeah, right. So over here we can choose GPU or GPU. So this is avoid using unless you need one. Okay, ready. Let's go GPU. Let's say I want to use them. So probably you're not going to go. So GPU is going to really fasten up all the simultaneous operation or the one that goes in parallel. So if you're using neural network libraries, probably if you have GPU, it's going to give you an answer in, let's say, less than a minute. Otherwise, it can take even 30 minutes on your regular computer. But if you have some single script like a Jupyter Notebook, we can just paste the whole thing on Google Colab and enable the GPU option. So you can see in our case, we are not doing any CPU intensive operations, so it's not going to show any difference if I use GPU or not. Probably because it's 38. So what I think is, just ending remarks is thank you everybody to just listening to me and learning a little bit about Python if you haven't. And at this point of time, if you haven't written or touched up like any Python code, and when you will start for in the beginning, you're going to come up with a lot of questions, a lot of errors. So probably it's good to consult your mentors or team members, or just Stack Overflow. That's probably going to be your best friend in writing code. Nobody else. Okay, thank you very much. So I'll be closing the whole conversation now.